we discussed what is mechanical power with example of trolley that we pushed to the hill, and this time I want to describe how we can calculate mechanical power, and yeah, of course, today we also will discuss it with our trolley. So again, let's assume that we need to push this trolley for some distance, and assume that when we pushing this trolley, we need to implement always the same force, so it's always similar. So we implement some force, and trolley goes from 0 to some distance L. And as we remember, if we multiply F and L, we will get work. So obviously, square under this figure, so F and L, will be the same as a amount of work that we did to move it from 0 to distance L. So it's very important to understand that square under this figure is the equal to amount of work that we need to implement. Let's now assume that we have a little bit more complicated. So this is, we push trolley not straight, but we need to push it to the hill, and it means that we always have to push more force to reach the same distance. So we start with some like F1, and then we push it to some value F2 more to be able to still to reach distance L. Very important that work will be the same. Also, work will be area under this figure, so we just need to understand how to calculate it, and it is quite easy. So if we take some point between F1 and F2, then our two these triangles will be the same, and area under this figure will be the same as area under this figure that we need to calculate. And we already know how to calculate this area. It will be F1 plus F2 divided by 2, because it's in between of F1 and F2, and we again multiply it on L. So I will write it. So work will be equal L multiplied F1 plus F2 divided by 2. So this is value that we need to calculate. So this is area under this figure. Why does it matter? Yeah, I already have it. Why does it matter? Because in some cases, in reality, it will be a little bit different. So it's not. It also will be here that more and more difficult to move trolley, and in reality, our figure will be a little bit different. In reality, our figure will look this way. And I think you already understand what do I mean. So in the beginning, I need to push a little bit force just to start moving. Then it goes quite better. So here I increase force and distance grows well. And then I need to at this point, so I need to push more and more force and distance increases only a little bit because like it's too high and too difficult to move almost vertically up this trolley. As you understand, it's totally the same as happens with the lungs. So when now we can just change force to pressure and distance to volume. You remember how we did it last time when we just divided force by square and multiplied length to square. So ventilator push air with some force and pressure. In the beginning, it has to just to start moving, to just opening alveolars, and then it goes better. And then when lungs already full, it requires more and more pressure just to a little bit increase volume. So it's totally ineffective. So that's how why this curve appears. And if we want to calculate work, the only thing that we need to do is just to split is to calculate area under this figure, and we need to split it to very small parts which we already know how to calculate. So we just we know how to calculate square of this figure, so we just split it to the small episode. We know that this is like pressure 1, pressure 2, pressure 1 plus pressure 2 divided by 2, and we need to multiply it to also this small volume that was increased. Then we calculate it to second part. We do it this way, then again, and finally we will calculate area under the whole this figure. That will be again equal to work of ventilator that pushed air to increase lung volume from volume initial to volume final. If now we divide it by time during which it was done, so as we remember, power, it is work divided by time. So if we divide by this area divided by time during which it was done, so inspiration time, we will get mechanical power of ventilator. That's everything that I wanted to describe during this episode. And next time we will discuss what happens during this time. So when we go back, what is this area and who does this work. So I hope it will be also interesting. If any questions, suggestions, ideas how to make this video better, please tell. I will try to include it in next series.